Well, here is a problem on quadratic and linear system. So that means we have one equation which is quadratic and the other one is linear. And we need to find the intersection of these two graphs. So let's look into the problem. Consider the function f of x equals to x squared plus 2x plus 1 and g of x equals to x plus 7. Determine the points of intersection of f of x and g of x. So basically at the point of intersection, those points will be common to both, right? So these functions f of x and g of x should be same, correct? So the strategy here to solve such problems is that you equate f of x equals to g of x and determine the points x for which both the functions are same, right? So let's start doing it by equating their values. So f of x is x squared plus 2x plus 1 and g of x is x plus 7, correct? Now we can bring all the terms to one side and then find the value of x. So it's like x squared plus 2x plus 1 minus x minus 7 equals to 0, correct? Now if you do this, it's x squared and 2x minus x is plus x and plus 1 minus 7 is minus 6 equals to 0. Now we can think about factoring this. So product and sum will be product p times q equals to minus 6 and p plus q equals to 1. I prefer to do this all the time to remind you that this is a very easy way of factoring, right? Well, so what the two numbers could be? Well, the numbers positive should be bigger and the numbers are 3 and 2, right? And 3 is positive and 2 is negative, correct? Yep. So that is how we are going to factor it. And so we get x plus 3 times x minus 2 equals to 0. Well, now this function is 0 for x equals to minus 3 or x equals to minus plus 2, right? Now, so to find we get the x values from here. So we get x equals to minus 3 and we get x equals to plus 2. So there are 2 points where the parabola f of x intersects the line g of x. And now we got the x values. To find the y values, we have to plug in this value in the function. Any one will do for us. But we should prefer to use line width. That's simpler to calculate, right? Simple to calculate. So find what g of minus 3 is. So we say g of minus 3 is equals to minus 3 plus 7, which is plus 4, right? And what is g of 2? So g of 2 is 2 plus 7, which is 9. Therefore, we can now write down the answer as coordinates, because we need to put the coordinates there, not just x values, right? So the points of intersection are so we have what? Minus 3 and the value of the function in minus 3 is 4. Let me write here. Minus 3 and 4, right? And 2 and 9. So these are the points of intersection. If you want, you can check the values, right? So if you plug in 2 here in the first function, so get 2 squared is 4 and 2 times 2 is 4. So 4 plus 4 is 8, 8 plus 1 is 9. So that's perfect, right? And if you plug in minus 3, so minus 3 squared will be 9 and 2 times minus 3 is minus 6. So 9 minus 6 is 3 and 3 plus 1 is 4. So we get this. So that means these points are on both the curves and they are the point of intersection. So that's the way to do a quadratic and a linear system. Well, algebraic way is always easier to do when the numbers are given like this, and in quadratic and linear systems always the best way to do. At times you may try to do them graphically also, correct? Well, it's up to you. But if you do this graphically, then Well, in this case, because the points are whole numbers, you may get as accurate answer as we have got here, right? So that's not a bad idea. And graphically, if you see fx equals to x squared plus 2x plus 1 could be written as x plus 1 whole square. So it's an easy graph, right? So if I have to sketch this, I can say f of x equals to x squared plus 2x plus 1. I could write this as, this is a perfect square, right? It is x plus 1 whole square, correct? And the line is x plus 7, right? So graphically was not a bad idea in this particular case. I could have drawn it like this. Now since I know the answer, right, I know kind of where it should intersect. But anyway, x plus 1 whole square is that your graph moves 1 unit to the left, right? So your parabola seems to be like something like this, correct? And when x is 0, it is 1. So this point is 1 for you. For the line is g of x is equal to x plus 7. So it's a positive slope but starts at 7. 7 is like way ahead like this, correct? Somewhere there, correct? And so, I'm not going that far. But anyway, you can see, let's say there's a break here, and 7 is like, if this is 1, 7 must be there, right? Or with a slope of 1, right? It's kind of, so what we hope is, let me draw another line which really intersects, right? And let's say this is my line which intersects. It's not true to the scale, but in any case, what I'm trying to show is that the line intersects at 2 points. So if you would have done it on a graph, then also you could have got very accurate answer for this particular question. Reason being that our point of intersections are whole numbers, right? But in case the point of intersections are not whole numbers, then graphical solutions can't be accurate. It's not very easy to read, like 2.25 or something like that. So the graphical will give a good estimate, but may not give you accuracy, right? So that's how it is, but any method can be adopted, okay? I hope you understand the process. Don't forget, sometimes I've seen that once the student finds the x value, then to find the y value, they just forget about f of x and g of x. They struggle putting the value here in this equation and they don't find any y, and they get confused. So they do get to this point of writing x values, but they fail to report the y values for the same. Remember, these are the x points at which the graphs intersect. So you could use any one of those functions and plug in the x in those functions and calculate f of x or g of x. Both, as we saw here, will give you the same point, right? And then you write down the coordinates like I have shown here. Fine. Thank you.